Hey you guys, we're going to look at Chapter 10, Section 2, and we are going to re-look at parabolas. This time we are going to focus on their vertex, their focus, and their directrix, given an equation. We're also going to use parabolas to solve problems. Hey you guys! So from Chapter 4, you know that a parabola has a vertex and an axis of symmetry. A parabola also has other characteristics. By definition, a parabola is the set of all points in a plane that are the same distance from a fixed line and a fixed point not on the line. So we can fill this in here with set of all points in a plane that are the same distance from a fixed line and a fixed point not on the line. So I'm missing a keyword here, not on the line. Now the fixed point is called the focus, and the fixed line is called the directrix. The distance between the vertex and the focus is the focus, or the focal length of the parabola. So in these pictures below, you can see that we have a vertical parabola, and we'll also be looking at horizontal parabolas. And by definition, it's saying that all the points on our parabola are the same distance away from this focus as it is from this directrix. So this length is the same as this length, just like this length is the same as this length. Any point on the parabola at all is equal distances away from the directrix as it is from the focus. And then same for her horizontal parabola. So first we're going to look at parabolas with the equation y equals ax squared. This is the standard quadratic form for a vertical parabola. And the equation for that is y equals 1 over 4c times x squared. So notice that a is being replaced with a 1 over 4c, or 1 over 4c represents what a is. Now, in standard form, our vertex would be at 0, 0. The focus is at the point 0, c, and the directrix is the line y equals negative c. Alright, so in our first example, we want to write the equation of the parabola given that the vertex is at the origin and the focus is at the point 0, 2. Anytime it tells us that the vertex is at the origin, we know that we can use our standard form. So we're going to use this form over here. Our focus being at 0, 2 lets us know that c is 2. So now I know I'm using y equals 1 over 4c times x squared, and I know that my c is 2. So it's going to be y equals 1 over 4 times 2 times x squared. And so the equation of this parabola will be y equals 1/8 times x squared. In my next example, it says the vertex is at the origin and my directrix is at y equals 3. Well, since I know that my directrix is y equals negative c, then I know that my c value is equal to negative 3. Also, since I know that my vertex is at the origin, I know I'm using the equation y equals 1 over 4c times x squared, and therefore substituting in for c, the negative 3, my equation for this parabola would be y equals 1 over 12, and it's going to be a negative 12, so I'm going to put that negative in front of my fraction, so negative 1/12 times x squared. You don't ever want to leave a negative number in your denominator, so you can just make that negative go in front of your fraction if you only have a constant in your denominator, like 12. So here's my equation, y equals negative 1/12 x squared. So now I want you to try these problems below. Oh, and I'm sorry, I didn't mention these graphs here. These are just pictures of what the parabola would look like when graphed. So you kind of have a mental image. Just like before when A was negative and it flipped your parabola upside down, it does the same thing. Same rules apply as before. Alright, so you try these two problems below, pause, and then continue on. Alright, now let's look at parabolas with the equation x equals ay squared. This is the standard quadratic form for a horizontal parabola, where again the a is being represented by 1 over 4c. So here our vertex is still at the origin at 0, 0. Our focus now is at C0. And our directrix is at x equals negative c. So notice the similarities between our horizontal parabola and our vertical one. Our focus, instead of being 0c, is c0, and our directrix, instead of being y equals negative c, is x equals negative c. Alright, so in our example it says, what is an equation of a parabola with the vertex at the origin? Again, cluing us in that we are going to use this formula above, and the directrix at x equals 1.25. Now above, the directrix tells us that x is equal to the opposite of c. So since x equals 1.25, we know c then is the opposite of 1.25, so c is negative 1.25. And then since I know that this is going to be on the bottom of a fraction, I'm going to make this a little bit easier for myself, and I'm going to change it to a fraction, and I know negative 1.25 or negative 1 1/4 as a fraction is negative 5/4. So when I substitute that into my equation, x equals 1 over 4c, it's going to be 4 times a negative 5/4. And this is times y squared. So here, when I multiply these together, my 4's cancel each other out. So I get x is equal to negative 1/5 y squared. Notice our graph above for standard form, it opens to the right, but since my a here is negative, it's a negative 1/5, and my graph it opens to the left. Next example says, what are the vertex, focus, and directrix of the parabola with the equation x equals 0.75 y squared? Well, we know the vertex right away. Since this is in standard form, I know my vertex is going to be at the origin, or at 0, 0. My focus is again at C0. So to find C, I need to say 0.75. My A value is equal to 1 over 4C. And if I can solve for that, then I know what C is. Now 0.75 is 3 over 4. So 3/4 is equal to 1 over 4c. And I'm going to cross multiply. I'm going to say 3 times 4c is 12c. And that's equal to 4 times 1, which is 4. And then solving for c, I'm going to divide by 12. So c is equal to 4 over 12, which reduces to 1/3. So my focus is going to be at the points 1/3, 0. And my directrix is the equation x equals opposite of c, so x equals negative 1/3. So there's my vertex, my focus, and my directrix. Alright, so you try. Here's these two problems. So go ahead and pause it and then continue on. Alright, so now we're going to use parabolas to solve problems. Above it says the geometry of a parabola implies a very important reflective property that gives real-world meaning to the word focus. As the diagram of the parabolic reflector shows, lines from the focus reflect off the parabola along lines parallel to the axis of symmetry. This is how a flashlight works. Conversely, lines parallel to the axis of symmetry reflect off the parabola directly into the focus. This is how a satellite dish works. In our example, it says, the mirrored reflector of a flashlight is 16 centimeters across and 10 centimeters deep. How far from the vertex should the light bulb be positioned? Alright, so I'm first going to attempt to draw a picture of this flashlight. So maybe here's my flashlight. And you know, the light's shining from it. Kind of looks like a cup. It says the mirrored reflector of the flashlight is 16 centimeters across and 10 centimeters deep. So maybe we have this parabola down here, this mirrored reflector, and it's saying that it's 16 centimeters across, so this is 16 across, and 10 centimeters deep. So this is 10 centimeters deep. So right here, we're going to call our vertex. And if I were to put this on a graph, I could say that this graph is right at the origin, just to make things easy. So what I'm going to do is I'm going to pick these points right here. I can pick either one of these points. Since I know it's 16 centimeters across, then I know this is 8 this way and this is 8 that way. So let's go with this point right here, this positive point, which would be the points 8, 10. Since I would go across 8 and then up 10. And that's going to be my xy. Well, since my parabola that I drew is right at the origin, and it's a vertical parabola, then I can use my equation y equals 1 over 4c times x squared. The question is, how far from the vertex should the light bulb be positioned? And that's really asking, what's the focal point, or what's the focal length, or where should the focus be? So we're trying really to solve for c. So I'm going to go ahead and plug in my x and y so I can solve for c. So 10 is equal to 1 over 4c times x squared, so times 8 squared, which is 64. I'll put parentheses around it. And to solve for c, I'm going to multiply 1/4 times 64, and I get 10 is equal to 64 over 4c. And I can reduce that fraction. That actually reduces, 4 goes into 64 16 times, so it's 16 over c. And now I can put 10 over 1 and I can cross multiply. So 10c is equal to 16. And then solving for c, I'll divide by 10. So c is equal to 16 over 10, which is the same as 1.6. And since our units are in centimeters, it's going to be 1.6 centimeters. So the question, how far from the vertex should the light bulb be positioned? It should be 1.6 centimeters away. So here's my answer. All right, so you try. And pause it, and then continue on. All right, so in Chapter 4, we studied how to translate a parabola from one with vertex 0, 0 to one with a vertex of hk. For such a translation, all of our other features, the axis of symmetry, the focus, the directrix, they translate along with the parabola and its vertex. So for a vertical parabola, where our equation is in standard form, and then it changes with a vertex of hk, our focus that was at 0c is now going to be at h, k plus c. And our directrix that was at y equals negative c is now going to be at y equals k minus c. Our horizontal parabola, as it translates, the focus that was at c0 is now at the point h plus c, k, and the directrix, which was at x equals negative c, is now at x equals h minus c. So notice the patterns there also from horizontal and vertical parabolas for the focus and the directrix. So analyzing a parabola. What are the vertex, focus,